tutorial on TensorFlow, a powerful open-source library for machine learning and deep learning developed by Google. TensorFlow is widely used in both academia and industry due to its flexibility and efficiency in handling complex computations and building neural networks. In this video, we'll walk you through the process of building a simple neural network using TensorFlow. We'll cover everything from setting up your environment to loading and pre-processing data, building the model, training it, and making predictions. Whether you're a beginner or someone looking to solidify your understanding, this tutorial is designed to be accessible and informative. We have to ensure that TensorFlow is installed in our environment. If you're using Google Colab, TensorFlow is pre-installed. However, if you're working locally, you can install it using a pip command. Pip install tensor will install the tensor library, so we can leverage the capabilities for building and training our own neural network. Now let's import the dependencies we'll be using. TensorFlow Keras and a few utility libraries, like scikit-learn for data processing. This code will import everything you will need. Now let's load a dataset for this example. We'll use a hypothetical chart where we want to predict customers' turn based on various features. We read the dataset using pandas and separate the features from the target variable. The train test split function divides our data into training and testing sets, with 10% reserved for testing. After that, we'll use standard scaler to standardize the values, ensuring they have the mean of 0 and the standard deviation of 1. This normalization process helps in speeding up convergence. Now let's actually build our model. With our data prepared, we can now build our neural network. We'll create a sequential model which allows us to tag layers sequentially. The first layer has 32 neurons and uses ReLU activation, which introduces nonlinearity into the model. The second layer has 64 neurons and also uses ReLU. The output layer has a single neuron with a sigmoid function, making it suitable for binary classification tasks. Now we need to compile the model. This step configures the learning process we're using. We're using the Atom optimizer, which is a very popular choice due to its efficiency in adjusting the learning rate. Loss function is binary cross-entropy suitable for a binary classification problem and will track accuracy as performance metrics. We'll train the model on 50 epochs, which means the model will see the entire dataset 50 times, a batch size of 10. The model will update its weights after processing 10 samples. We'll also set aside 20% of our training data for validation, allowing us to monitor how well our model performs on unseen data. After training, we can use our model to make predictions on our new data. The predict method generates predictions on the test datasets. We then convert these predictions into binary cases by applying a threshold of 0.5. This means if the predictability is greater than 0.5, we classify it as a 1, otherwise a 0.
Thanks for watching. If this video was helpful, please like and subscribe to our channel for more tips and tutorials.